So today what we're going to do is we're going to look at another way to solve a system of equations. And this is called elimination. Now what is the root word of elimination? What is the root word? Eliminate, right? And what does eliminate mean?
Take away.
Take away? What would be another meaning for eliminate? Get rid of, yes, good call. And so in order to solve by elimination, step one, we're going to write the system so like terms with the same or opposite coefficients are aligned. Okay, this is taken from your book. I don't know if you necessarily need to write these down because we're going to go through these steps as we solve the first few problems. Step two is to add or subtract the equations, eliminating one variable. Then solve the equation. Step three, substitute the value from step two into one of the equations and solve for the other variable. Write the solution as an ordered pair. So let's go ahead and look at this first one. The first step is to write those so that the variables are aligned. And if you look here, when I say aligned, that means the x's are in lines with the y's. And they're aligned right now. You see that? Now our whole goal is to eliminate one variable, whether it be the x's or the y's. And so things I'm looking for the same coefficient with opposite signs. So if I look at the x coefficients, what's the coefficient here? 4. What's the coefficient here?
3.
Are they the same coefficient? No, okay? Let's look at this one. What's the coefficient of this one? 6. What's the coefficient here?
-6.
-6. And so it's the same coefficient with opposite signs, which is what I was looking for. So what I'm going to do now is I'm going to add those two equations together. Why do I choose to add? Because what do I know about +6 and -6? They give you 0, right? And that's our utmost goal. I want to be able to add variables together and get 0. So let's go ahead and add. What is 4x plus 3x? 7x. What is 6y and -6y? 0. So then next comes an equal sign. What is 32 plus 3? 35. So now I've only got one variable left. I'm going to go ahead and solve that. What?
Could you subtract them too?
No, we don't want to subtract right now. Okay, so then what am I going to do here? Divide by 7. So what happens on the left side here?
7 cancels out.
Yep, and I get x equals 5. So now what I need to do is pick one of the first equations. It doesn't matter which one. Either the first one or the second one. I'm going to pick the first one just because the second one has a subtraction sign. Sometimes we make mistakes. And in place of x, I'm now going to put 5. So I have 4 times 5 plus 6y equals 32. What is 4 times 5? 20. How do I solve that for y? Subtract 20, very good. Then what do I do next? Yep, so I have 6y equals what? 12. So then now I'm going to go ahead and divide by 6. So I have y to equal 2. So my ordered pair will be 5, 2. That is elimination. Let's look at another one. Now remember, our whole goal is to eliminate one variable. So I'm looking for the same coefficient where one is positive and one is negative. So in this system of equations, what variable could I eliminate? What variable?
X.
X, okay? So let's go ahead and add those two together. So if I add these two equations together, negative 4x and positive 4x is 0. What is 3y and negative 5y?
Negative 2.
Negative 2y. What is negative 3 and positive 5? 2. So to solve this, what am I going to do? Divide by negative 2. So I get y to equal negative 1. Now it doesn't matter what equation we sub in. We could sub it into the top equation or the bottom equation. But in place of y, I'm going to put negative 1. So really I get negative 4x plus negative 3 equals negative 3. What do I do now? Add 3 to both sides. So I get negative 4x to equal what? 0. What do I do now? Divide by negative 4. So what does x equal? 0. So my ordered pair is 0, negative 1, because remember x always comes first. So what do you think of elimination? You like that a little better than substitution? So we're going to look at a few more just to make sure we have it down. Oops, let's go back.
So do you always add them? At the beginning?
I prefer that you add them. You will make mistakes if you subtract. So, as you're writing this down, what do you notice? Yeah, they're opposite because the x's aren't lined up and the y's aren't lined up. So I'm going to write those around. So what I'm going to do is rewrite this equation right here. And I'm going to rewrite it underneath the existing one.
Do you always rewrite the top one?
No, I just chose to do this one. I mean, you could rewrite the bottom one too, it doesn't matter. So what will go first?
X.
3x, yep, plus 4y equals 22, good. So now these are the two equations I'm going to go ahead and add together. So what is 3x and 3x? What is negative 4y and positive 4y? 0, which is exactly what I wanted to have happen. What is 14 and 22? 36. So now what do? Divide by 6, so x equals 6. So now I'm going to go ahead and plug 6 in. It doesn't matter which one. I could plug it into the top one or the bottom one. So I could do 3 times 6 here, plus 4y equals 22. So 3 times 6 is? Yeah. So now what do you need to do? Subtract 18, good. So I get 4y to equal 4. What do you do now? Divide by 4, and I get y to equal 1. So my ordered pair is 6, 1. Alrighty, oops. Skipped one, there we go. Now we've got 2 more we're going to look at. So I have 6x minus 9y equals 111. 5x minus 9y equals 103. Now, what do you notice? They're both negative. I don't have an opposite sign. So if you remember from the very first slide, it said you could add or subtract. I don't like to subtract because generally we make a lot of mistakes when we subtract. So what I'm really going to do is I'm just going to change all of the signs on this bottom equation, because that's kind of like subtracting. And then I'm going to add the two equations together. So now if I add those two equations together, I get 6x and negative 5x, which is what? 1x. What happens to your y's? They're gone. Equals what? 8. Good. So now that's actually my x value. I can plug that in. I don't have to worry about having to divide now. So I can pick an equation. Once again, I could just pick the top equation. Doesn't matter. So I have 6 times 8 minus 9y equals 111. So what's 6 times 8? 48. What do you do now? Subtract 48, very good. So I end up getting negative 9y to equal 63. So now what do I need to do? Divide by negative 9. So what do I get y to equal? Negative 7. So my ordered pair is 8, negative 7. Good. Questions? Feeling pretty comfortable with elimination? It's actually my favorite too. But let's go ahead. Oops. Let's skip that one. Let's go ahead and look at this one because this one is a little different. And this is the last one we're going to look at, and then we'll be done for today. So 3x minus 5y equals 11. And then I have 5 times the quantity x plus y equals 5. Now I want you to look at that and I want you to think, okay, what would be a way that I could solve this problem? Just take a guess. Distribute, perfect. That's exactly what I need to do. I need to distribute this 5 so that I get an equation that looks similar to the top one. So if I distribute that 5, I really get 5x plus 5y equals 5. Okay, now what I'm going to go ahead and do is I'm going to go ahead and move over my other equation so that it lines up. Because remember, that was one of the things they said to do, to align our two together. So let's go ahead and add our two equations. And what do you get? Equals 16. Good. What do you do now? Divide by 8. So I get x to equal 2. Now once again, it doesn't matter what equation you plug in. You know, I could plug in, I would probably plug into the top equation though, just because I haven't done any work on that. So I've got 3 times 2 minus 5y equals 11. 3 times 2 is 6. So what do you do now? Subtract 6. So I get negative 5y to equal what? 5y to equal 5. Okay, and then what do I get y to equal? Negative 1. So my ordered pair is 2, negative 1. So you like elimination? So this is what I need you to do. 7 through 18, 26 through 28. Now once again, if there's something you're not understanding with the elimination, you have to get in and get it fixed. Okay? So for tomorrow, page 354, 7 through 18, 26 through 28.